7. All right, good evening, everybody. Welcome to a very cold evening. Okay, so are you all here for 441, 541? Yes? Okay. Network Applications Administration. Okay, just want to make sure. Okay. I'm Kevin Vaccaro. I'll be your instructor. Okay, I've been here for quite a long time. I got my master's from here, so I was a student here, and I'm currently a student getting my doctorate. So I know exactly what it is to be a student. I know what it is to work all day. I do all that. Okay. I teach at several colleges, so I'm well aware of a busy schedule. So in this class, I'll go over the syllabus. What you're going to learn is we're really going to do a lot of, you're going to build servers. Okay, so they're going to be Linux servers you're going to build with a client. Okay, and you're going to do protocol analysis. I think you learn more about the application layer, which is services, better if you build the stuff yourself and then analyze the protocol. That way, if you look at something going through the pipes on a network, you'll understand what's going through there. You know, now I broke a couple protocols. I had to remove the encryption so you could actually see them. So because you can't read encryption, it's all, and I'm not going to trying to inject the private keys a pain. So some of the labs, if you've had a chance to log in, you'll see there's about a lab a week. Okay, so each protocol each has a lab. This week, of course, so you're going to have to build your environment. Okay, so how many of you use Mac? Use Mac? Okay, is it an M series? Okay, I would suggest using UTM. Okay, because it has pre-built machines in it. So all you have to do is after you install UTM, download the pre-built Ubuntu's, and it'll make your life easy. For everybody else, I recommend Oracle VirtualBox. It makes it a little bit easier. Okay, since VMware is dead, it's been thrown out the door. Broadcom doesn't support it. Well, they kind of support it. I would recommend just use Oracle. It's free. You can do it. Okay, cool. All right, yeah, I use it on my Mac, so it's not a problem. I really don't care about operating systems anymore. They're all the same to me. I run Linux, Mac, and Windows, so it's all the same to me. So, all right, so let's go over what the course is going to entail. Basically, they're very similar. 441 and 541. You're going to cover, this week I just want to go over what you remember from basic TCP/IP. So you've all had 340, whether now or at some time in your career. So just basic review, how to use TCP dump, how to use Wireshark, what the protocols look like, just some basic review about structure and how how that works. You're going to cover pretty much every protocol around. I've added them in here. These are all popular protocols, pretty much used everywhere. Okay, a lot of the hackers use some of these older protocols. So you might wonder, why is there Telnet? A lot of people go, why is there Telnet? Because they actually use it. Because people forget that it exists and you could detect it, they use it to transport data out of people's networks. They still use some very old protocols because the malware will use it to move data. So if you can detect it and understand it, you can see what they're doing. So it's always good to know because you see a lot of sewage in these pipes. I've seen all kinds of data going through. And there's a lot of new protocols out there that haven't quite made the prime time. Stuff like Google has a protocol called QUIC, QUIC. It is an RFC, but it hasn't been accepted by everybody. Okay, so there's a lot of things going on, a lot of newer protocols, even the protocols that they use for crypto has changed. Some of the protocols they use to do mining and a lot of other stuff have changed. They've actually come up with new protocols for specific usage. I'm not covering those. I'm doing the main ones that you see every day pretty much on a network. So this week, once again, there is a book for this class. It is not very expensive. I tried to pick the cheapest little packet book. It's by Chris Sanders. He's taught a lot of SANS classes, and it's a small book, but it's a nice book. It doesn't cost much, and it covers a lot of basic protocol analysis. Okay, makes sense. As a lot of the books have a lot of more certification driven on more of just general protocol analysis. Okay, so every week we'll do that. There is a midterm and final. They are online. So when I turn them on, you'll have a period of time. I usually give you a day or two, sometimes 3 days to do them. Okay, you do them at your own leisure, 24/7. They are timed. Okay, so once you start them, you have to complete them. Okay, and there's only one take on each. All right, but that'll work around your schedule because I know you have multiple classes. I'll tell you when they're announced. I will turn them on, and you go ahead and take them. Once the timer runs out, or if you've complete, it'll automatically grade you. You know. Okay, so it's very simple. All right. There is a spring break in this class, so around the 19th we get a spring break. And the final exam will be online. Okay. There is a paper due in this class. Okay, so at the end, I give you the actual template. It's an APA formatted paper. I give you the template, so you don't have to go hunting for a template. Okay, the format I want. And you're going to write a paper. Now, if you are a graduate student, obviously I want more. If you're 500 level, I want a little more pages than a normal. If you're an undergrad, you don't have to do quite as many papers, and it's in the syllabus, how much you have to write, okay? And it's on any protocol, whether it's in class or any other protocol you may research. You can find tons of them on RFC Editor or whatever you like, and there's a lot of newer ones that have come out over time. They're kind of interesting what they're using them for, okay? Different ways of improving the internet. You have to remember the internet's a service. Was developed in 1969 as a service, but originally these protocols were developed so that it was under DARPA, and they really wanted for the DoD wanted it to basically talk to missile silos. Basically, that was the original, and universities developed an open source protocol, and that's where we have TCP/IP. Okay, but the history of this really goes back to the military. They needed something to communicate. You got to remember, machines back then were mainframes. These were not little desktops or laptops like you enjoy today. That didn't exist. So this was all through, and machines couldn't talk to each other. So that's where you have OSI model standards so that things could talk to each other. Okay, so that's kind of the history. So you'll write a paper at the end. Now, I'll talk about the elephant in the room, right? I talk about the AIs, right? The chat GPTs of the world, the perplexity. Here is my opinion. Everybody ready for this? Okay. You have a great computer on hand. Do you know what that computer is? You carry it with you every day. Yeah, exactly right. It's between your shoulders. Okay. That thing is not intelligent. In my opinion, it's not intelligent. It just feeds. You feed it enough info. Somebody writes in a logarithm, gives you data. I've played with most of all of them. Sometimes it hallucinates and gives you the wrong answer. Okay, it's a tool, just like the calculator is a tool. Don't let it do its work for you. Okay, don't plagiarize. Don't standard spiel. Just write it yourself. Okay, if you want to have it go look for resources, you can. You could say, can you find me resources on this particular protocol? It will, and it'll probably give you a bunch of them where you can look stuff up on a protocol. Use it as a tool. Don't use it as a substitute for the computer on your shoulders. Okay. Believe me, it's not going to troubleshoot this shit in the field. I know. I've used this to troubleshoot. Any gamers in here? Yeah, I've used it to troubleshoot slow connects on games and figure out what they screwed up at the other end. Steam did it a couple times. Their servers were screwed up. I could pick it up on protocol, and that's the problem with Steam. And you use it to do a lot of things. I used to do analysis a lot of times of different things. I use it for attack analysis, for incident response. So understanding the protocol, working with it. Okay, so don't use the tool as a crutch. It's a tool, okay, but don't let it write your paper, okay? Everybody clear on that? You're all adults, you know better, okay? That doesn't, and let me tell you that that's not, they want to make it more than it is. I know professors here have worked on it since the 70s. They'll tell you it's overhyped. They've worked on the original ones. I actually worked on one of the original languages back then. Okay, they're okay. You know, they're tools like a calculator. So don't let them substitute your brain. Okay, you have a great tool on top of your head right here. Okay, cool. Everybody good at that? Don't plagiarize, please. That's there's too much out there like that. Okay, don't do that. Okay, quotes, do everything. I'll give you the APA template. Okay, cite your sources. Very simple. Okay, go with that. I'm a simple kind of guy, not very complex. Okay, just follow the rules and we're good. Okay, all right. Once again, you know, I give about 20. The lab assignments 25%. Midterm will be 25. Final exam 25, and research paper 25. So it's kind of an even split between everything. Okay, all right. Cool. Like I said, for the grad students, the 5, I expect, and if you read the syllabus, a little more length to your papers. Okay. There's a little bit more. Okay. Just don't give me full graphic picture. I mean, don't put a picture in there for no reason. Okay. If you're going to put something from an RFC in there of a diagram or something, just don't put it in there and say just a fill space. Okay. I just want you to really understand whatever protocol you choose. Okay. Make sense? Okay, any questions about the syllabus, how the class will run? Okay, now there's 2 recordings, okay, and I'll give you a little thing else I do. So there's 2 recordings. There's the Panopto. Right now I'm using Camtasia, and so I'm going to record this and put it on YouTube. It'll be in my private channel. I'll let you have it. So when you want to have a few laughs, you can walk around with your phone and watch it on YouTube. Okay, so I'll have it available for you. It takes me overnight to process, but there will be a YouTube recording as well as the college doing Panopto. Okay, here's the other thing. If you happen to go into Shell in the Canvas and you looked at Zoom, I actually have a Zoom link running every class session. For some reason, if you're sick or you can't make it or something, you can join the class on Zoom. Okay, that's not part of the normal thing, but I do it because I want you to have access to education. Okay, so if you can come, if you can't physically come, you can use the Zoom. If you can't make the Zoom, you have the recording. So you have 3 methods to say you have access to class. I want you to get the material. Okay, cool with that? Are you here for 441, 541? Okay, you're good. Okay, all right, so, all right, any questions? So I run it through Zoom, I run a recording, plus the college does recording, and I do a live session. Okay, all right. If for some reason the weather is completely crap and we can't get here, I will do this over Zoom. Okay, because I don't want you freezing to death. I don't want you to walk through, snow and that. I was a student. Okay, so if something happens, I say I'll be on Zoom. That means we won't physically meet. We'll do it through Zoom. Okay, occasionally that happens. Okay, sometimes the weather goes bad or I get called out to do sometimes I have to speak somewhere, but usually not, but sometimes I do. Okay, cool. Any questions? Pretty straightforward, right? It's not that bad. Okay. Have all of you worked with Linux at one time in your life? Okay, because these are Linux servers, Linux clients, so you don't have to be a pro at it, just build them. I'm going to use Ubuntu in a class. If you're not comfortable with Ubuntu, choose your Linux version. They all support all the services, okay? Whatever floats you. What you're really trying to do is set up a client server and then generate and install the service and then do a capture of the service. Okay, cool. Questions? Okay. There is no TA for this course. So just so you know, I am my own TA. Okay, so if you need to reach me, email is usually preferable. All right, so I usually put it they now make me put it here at the front. Okay. This is my Google number. Okay. If you send me something like a Google Voice, okay, please tell me what class you're in. Pretty please. Because I teach a lot of different classes. I like to know. Don't say, hey, this is Celia, or this is Joe, or this is Jane from Micah. I teach a lot of, tell me you're in ITM 441 so I know. Okay. If it's urgent, you can do it that way. Email's fine. I check my email 7 days a week. Okay. I try to get back to you as quickly as possible. Okay. But send me email. If something comes up and you really want to meet, it's okay. I can do virtual meetings. Okay. I do work weekends. I can make virtual meetings. Okay. I can set them up for you if you need. Okay. I usually get here about an hour before class. Okay. So usually you'll see me hanging out and that. If you need to talk to me physically before class, I'm usually here about an hour. If you want me to go to the student center and talk to me or somewhere. It's the first time I'm in the basement of this building. But anyways, if you need to talk to me, come talk. Don't let things fester. This course is 17 weeks or 16 weeks long. It's easy to get lost and fall behind. Okay, just come talk to me. That's all I ask. Just say, hey, professor, or hey, you. Okay, you can call me anything you want except late to dinner. You can't call me late to dinner. But anyways, whatever you feel you're comfortable with. If you feel more engaged one-on-one, that's fine. If you do it virtual, it's fine. You want to do it email, whatever, just come tell me. Okay, life happens. I'm not going to blind that. Okay. Okay. When I was in the master's program here, I was in Wheaton, Illinois, in a little building that you probably never saw that they own out in Wheaton. It's on Ring Road. It's actually owned by IIT. And I was in a room about half this size, and that was the program at the time. And I used to work 8 hours, and I'd have to go to school till 10. So I had two little children at the time, so it was really fun for 2 years. So I understand. Okay, life happens. Just let me know. Okay, you run into something comes up, illness or that, just contact me. Okay, I'll work with you. Okay, I'm not that unreachable. Okay, cool. Any questions about the course, the syllabus in general? No? Cool. All right. Like I said, I'm pretty reachable. Okay. All right. Syllabuses are posted. Like I said, the difference between 441 and 541, I expect a little more out of the graduate students. Okay. This is an in-person course, but of course it's recorded, and of course nobody knows, but I do the, if you want to see the Zoom link, just go to the Zoom on the left and say you're sick or something happens, click on Zoom, you can join the class that way. Okay? Cool. Just don't all abandon me, because it's kind of hard to talk to four walls. Okay? Very difficult. I've done it, but it's not fun. Okay? Sound good? All right. All right, so you got 3 methods to get the material. Every assignment will be due weekly. So like this week, you're just really going to build your environment, make sure it's ready for you. Next week, we'll start really the protocols. And you'll build your first server, and that'll be due, the write-up will be due the following week. Every write-up I've laid out for you in the modules, so you don't have any really lab this week. You're going to learn, just review. But next week, we're going to do DNS. Okay, we're going to build a bind server. And we're going to go through what DNS is, the new types of DOT, which is their encrypted DNS queries, things like that. We'll go over all the RFs, talk about the RFCs, and then your homework, which all the assignments are at the bottom. Your first one will be build a DNS server, which is somewhere in here. I know I put it in there. But I also put in what are the requirements for the report. Okay, so you take a screenshot of all your capture. You use Wireshark. Everybody use Wireshark in here before? Seen it, smelled it? Okay. It's really effective. If you want to do it quickly, you can use TCP dump. Grab the whole file and then throw it. Wireshark's really a parser. You don't use that in the field. You use TCP dump because it's just non-graphical. You drop all the traffic and then throw it into Wireshark for analysis. Because Wireshark has its limitations because you can blow it up if it's too big. Okay, so if you grab it as a raw PCAP, it's a lot easier. And actually, if you do any kind of threat hunting or what they call threat hunting, you actually use the command line version of Wireshark because it can handle very large drops. Okay, the GUI can't handle very large PCAPs. It tops out and crashes. Plus, because you are capturing raw traffic, malware, they've developed malware that will crash your sniffer. So you really don't want to use a graphical sniffer on traffic because you never know what they're going to put in that stream because you're capturing a raw stream. And if there's malware in there, it'll extract it. That's the other problem. Okay, so grabbing it raw, less likely that something's going to happen. You can analyze it later. So once again, I want you to take a clear screenshot and then explain what's going on with the protocol. Okay, just don't say see traffic, right? I want to know that you know what's going this way, what's going that, or what's happening. At first, it'll be simple. You'll kind of laugh because the protocols aren't complicated. The early ones are we still use them, but as you get more complex, like Samba or LDAP or those have a lot more functionality. NFS, there's a lot more things going on. Okay, so it'll get a little more complicated as the course goes on, but I like to see your work, a screenshot of your capture that. You can upload the PCAP with the report. And it's not that I don't trust you, is that a lot of times what happens, here's what happens. Somebody submits and they go, I couldn't capture a thing. So I download the PCAP, I open it up, the protocol's there. They didn't know how to filter. Okay, so I'll verify what you got there for you. Okay, I only do that in cases where they're not sure if they actually captured the data. Okay, so I can look at the PCAP and take a look at it. Okay. That way, sometimes you've done the work, you just don't realize it. And then I say, well, yeah, you did it. So you just didn't see it. Okay, so you didn't filter right. Okay? Every report will be in that format. You got a paper, not a paper, well, just a screenshot with explanation, and then include the PCAP with it. Okay, just upload it for me. Cool? All right. All right. Questions, comments, concerns? Pretty cool. No, pretty straightforward. I'm not very complicated. All right. Let's start with, let's see, I think one of my VMs took a dive, I think. Did you dive? No, it worked. Okay. So let me go, before we start the review, let me go over just how to build the environment. Okay. So I give you some recommendations for server and desktop. Now, if you're not comfortable with just raw command line, you can do this with two desktops. Does that make sense? Okay, so if you don't want to load Ubuntu Server and Ubuntu Desktop and you feel comfortable with the GUI of Ubuntu Desktop, you are welcome to just put in two desktops to do this because the desktop is essentially the same as the server, okay, for our purposes. It'll load all the protocols, all the services, okay? So if you're not comfortable like running raw server, like, like so, if you don't like the world of non-GUI, you're welcome to do two desktops if you want, whatever, because one of them is going to be your server regardless. You're going to load your services one at a time. Every week we're going to load something. Like next week we're going to install Bind. You're going to become a DNS server, okay? And then the other one will access it, and then you'll capture traffic. Does that make sense? So what you're going to do is a pass-through DNS server, so you'll watch how DNS traffic looks when it's unencrypted across the network. Okay, remind me later. Okay, cool. All right. So, but if you're not comfortable with just a black screen like this, you're welcome to do it with two desktops. I'm not really teaching server class. I'm just, for purposes of the class, so you can get the traffic. It's up to you. I do recommend loading the server. It just has no GUI. That would be sacrilege. Any Linux person would say, you put a GUI on a server, they run just as that. And you could always, if you just want to be, you could always SSH over to your server. You can do, remote to server. I forgot what IP this thing is. This is 10.02.23. Go away. I hate the new one. Every time Ubuntu comes out with a new one, they try to make it more like Windows. It drives me nuts. 23. You could always SSH into your server. It's wrong password. It's going to yell at me. Yep. And now I'm on the server remotely. Okay. So protocol we'll learn. SSH is a protocol. Okay, but we'll learn it. And now I'm actually on the server. I don't even have to touch it. I can actually install stuff on the server if I choose to from now. Okay. So I'm actually on the server anyways. So I don't have to actually sit on it if I don't want to. Okay. All right. So some basic stuff. So what I recommend is if you've never downloaded Ubuntu, okay, so you'll need Ubuntu. If you're running a Mac, you could simply download it into UTM. They have it in there. You could just download it's slow to download. I don't know why their servers are slow. So start the download and then go to bed. It'll be done by morning. Okay, it's very slow download. But Ubuntu is an easy distro. Okay. Once again, once you go to Ubuntu, there's the desktop. Okay. And there's a server. Okay. Cool. Makes sense. Simple enough. That's where you get the ISOs. And you can download. I'm using 24 right now. If I remember right, I'm using 24. So I will use the latest edition of it. So it depends on, that usually works fine. If you're comfortable with Fedora or some other version and you can load the services up, have at it. I am not strict to Ubuntu. I just make it easier for you. Okay? Cool. Some of the other thing is I gave you a link to help you out here. It's in the class, but if you go to Server World, there's a link inside of Canvas. I put it there. You tell it which OS you want to learn about or what service you want to. Now, they're a little bit complicated. Some of the stuff I do is less complicated. 24 just came out, but they have 24 in here. And all the different services, they tell you how to put them in. I'm going to simplify this because some of the stuff they do is way too complicated for what you need. Okay. But I'll simplify it for you. Okay. You also can go to Ubuntu's documentation and it will walk you through a very simple install. Okay. Has everybody used Oracle in here before? Oracle VirtualBox? Yes. It's very similar. It's actually, I found it better than VMware, but that's me. So if you've used it before, you can use it on a Windows box. There you go. Just download it. Okay, I do recommend to when it says put the extensions in, I would put the extensions. It'll help you. Okay, there are some extensions that come. So download and install it. You don't have to use up a lot of your hardware. Okay, remember virtualization uses the underlying hardware. Okay, so depending on how much RAM you have, remember the GUI-fied version of Ubuntu takes a little more RAM, otherwise it's going to be very slow. Okay, the server version without any GUI, you don't have to give it so much RAM. So if you have an 8 gig machine, you're going to have to eat up at least 4 gigs, at least maybe 3 and 2 or 2 and 2, depends on the performance. Okay, and then hard drive space, make sure you have enough hard drive space. Usually about 25 gigs is good for each one, but make it dynamic. Don't make it persistent because it's not going to eat all that up at first, but as you go along, you're going to eat more and more space. Okay, cool. Questions on that? Okay. I don't recommend VirtualBox to run on a Mac. It just doesn't work right. Okay, I like UTM works much better. It's what I use. So if you don't know, for those of you who don't know, it's a kernel. It's kernel virtualization. You can run it on iOS, and particularly it runs on Windows, but it runs better on a Mac than it does on Windows. Okay, it's a kernel virtualizer. It's a neat little tool. Okay, questions? I do give you some recommendation on config. Bless you. So I do give you some recommendation. Not that one. On installs, whatever floats your boat, but at least 2 gigs and about 30 or 40. Also, if you've worked, I don't know if you've worked with it enough, Oracle is designed as these machines, when they're installed, will only talk out. They do not talk between each other. Okay, so I'm going to show you how to fix that. Okay, UTM does not have this problem. Okay. You want each one to have an independent IP, otherwise they will all both be 10.0.2.15. How you fix that is File, Machine, where's Preferences? File, Preferences. You go to, they keep moving things around on me. General, that's fine. Language, that's fine. Interface, that's fine. They moved it around on me again. File, oh, tools, there we go. Network Manager. You need to create a net network. That's not there by default. You just hit create and create a net network. Okay. What that will do, there is a virtual switch inside of Oracle. Okay. That will allow both machines to get independent IP addresses and then go out in the internet. It basically has a virtual router in there. So what happens is both machines will get, after you create them, will then put them on the NAT network that you create. Okay, everybody get out at what I just explained? Because when you set them up, when you build them in VirtualBox, and you look at, they will not install like you think. There's a network, but note, I put it on a NAT network. By default, it puts it on NAT. NAT only allows it to talk out and will not allow it to talk to another machine. You need the two machines to talk. I'm telling you that 99% of the problems I run into on the first week is, I don't see anything, I can't get, because you didn't put them on a NAT network. They have to talk to each other. They cannot have the same. By default, when you install a virtual machine inside of Oracle VirtualBox, it only talks out to the internet through your machine interface. It creates a virtual. Okay. So you have to go, once again, when you're going to install, and usually you have to do it after the fact, you need to go, the new version of Oracle does File, Tools, you go to Network Manager, and you go to NAT Network, second tab, and this will not be there. You just hit Create, and it'll make it for you. And then configure each one of your machines to connect to the NAT network, not NAT. Okay? You will then get anything you need. You could download from the internet and stuff like that. Okay? Cool. Otherwise, they won't talk to each other. They're not designed, it's not designed to, what this is designed to do, it's a hypervisor. It's a type 2 hypervisor. What it's designed to do is you build all your machines, they talk out on the internet, but they don't talk amongst each other. You have to put them on a network together. Okay, there's a software, there's a virtual switch in there that allows that to happen. Cool? Make sense? Okay, simple enough to use. It's not hard to use. It's just that's one of the main sticking points I run into. Somebody forgets to put them on that network. They both get the same IP, 10.0.2.15, and obviously they're not going to talk to each other. Okay. Okay. So when you set up your environment, make sure you set those two up. You can let it install. Okay. Ubuntu actually, if you dig around, now I showed you how to do it with an ISO. You could dig around. There's lots of versions. There's actually a place called osboxes.org, and you could actually download a pre-built Ubuntu if you'd like. Okay, you just download the machine and then you import it into your VirtualBox. Okay, I recommend you install from the ISO. You have better control, and all of you know what YouTube is. Okay, you can find 10 million YouTubes on how to install into VirtualBox. Okay, it's very easy. Okay, it'll make your life a lot easier. Plus, you get an idea of how to build a machine, so you'll see what the differences are. Okay, questions on this? Setting up your lab environment. This is on your local box. Yes. Pick one, whatever you're comfortable. Okay. If you're going to run on large Linux servers, you will not have a GUI. Okay. Large Linux servers that run most of the internet do not have GUIs. The desktop ones are for people just normal, just like we have Windows or Mac or anything else. Okay. If you do both, then you kind of get a handle on both. Okay. Because some of the problems you'll run into is like Wireshark, you really need a GUI for it. You can run Wireshark without it, but you're not going to like the switches. It's a lot of switches. Okay. There is something called T-Shark. T-Shark is the command line version. It's very nice, but it's a learning curve. Okay. So you might want a client that's GUIfied and then a server that's not. Okay. Just to make your life. If you want both to be two desktops, that's fine too. It's just that now you got a GUI to work with. Okay. Like I said, it's not a Linux class. It's about network applications, operations. I just want to make it so you get, you know, used to working with stuff. Okay. If it was a Linux class, it'd be much more painful. I'd make it more painful. Okay. All right. Cool. All right. That was a good question. Okay. Industry tends large scale servers. Windows is not a large scale thing they use, usually for only internal. All the internet servers are Linux based. Most of them, about 90% of them. Okay. They're just big Linux boxes. Okay. Internally, a lot of people run like Active Directory Windows to manage all their internal, which makes perfect sense if you're managing your environment, AD, which is an LDAP. We're going to find out it's just LDAP. It's their version of LDAP, and that they actually got that from NetWare, but it's another story. But it's LDAP compliant. That's what it is. Okay, you're going to build something very similar, just not GUI. Okay, cool. All right. Protocols are fascinating. There's a whole art form to it. We're going to just do very simple one at a time, understand them, what's going on. Okay. It could tell you a lot. It's kind of interesting what you find. Okay. The internet's only about 35, 36 years old as a service. Okay. Like a lot of people, when Tim Berners-Lee created HTTP, he actually used two protocols you're going to learn prior to that to make it. He didn't. It's not an original. It's original in the fact that he hypertext and connected things, but he actually took two preceding protocols we're going to learn in this class, put them together to create it. So it's not like he wrote it from the ground up. Okay. I'll give him that he invented the idea of hypertext and the internet idea. Internet's not a protocol. It's just a massive connection of multiple. When you took your pre-class, you'll find that everything's just a network of networks. Okay. Large scale ASN numbers differentiate different parts. The protocols you use there are OSPF. Internal, you have RIP routing internally or internal routing that they do, but on large scale, they're using BGP to talk between large ASNs, okay, through all the different ones. I know this goes back a ways and probably, but that's how the internet's just large scale, yeah, interconnecting of networks. Okay, that's all it is. Internet's a service. Okay. The original one was in California in 1969. They connected two big computers together, big mainframes, and then it grew from there. Okay, cool. I have a lot of history in my head. You just gotta allow for me. I have stories because I go back before the internet existed. I remember when TCP didn't exist. TCP/IP didn't exist till the early 90s as to be used. Most of the protocols were not TCP. The TCP/IP really didn't roll out till the 90s, though the protocols are older. Okay, cool. All right. Questions on what you need to build, about building it. So if everybody built virtual machines in here before? Okay, so it's not a big stretch. Okay, I'm not using containers. I'm not doing any containers or anything, just straight out machines. Containerization is another fun thing you can do, but I'm not doing any containers. Okay. All right. So once you get those two up and running, you'll be able to, and how do you test the connectivity between the two machines? Ping. There you go. I knew somebody would say, you just ping it. It's just an ICMP message between the two. You should be able to ping between the two. You're good to go. Okay. And if you want to check if you're connected to the internet, just type dig. You should get all the internet routers. Okay, A through M. Okay. That means your DNS connection's working correctly. Okay. Makes sense? Your resolver's working. Simple. That is basically, I don't grade you on building your lab. I just want you to build it and have it ready. Okay. I don't respect the report on your build. I just want you to have it ready. Okay. All right. All right. Let's review some basic TCP/IP. Okay. Has everybody taken their precursor recently or about a year ago or just recently? Yeah. Last semester? How about all of you? Second semester? Okay. I mean, within the last year, 2 years, how far back the precursor to this? Yeah. Recently? Year and a half? Okay. So I'm going to jog your memory. Okay. I never assume everybody remembers everything. Okay. I'm going to jog your memory a bit. Okay. Do, 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 do. I'm going to give you a little bit of jogging of your memory. Okay. So I covered this. I gave you a cheat sheet. Okay. Just basic Linux commands. Okay. I can give you about a million other ones that you can use, but just some basic ones. I'm going to play mostly with TCP dump today and a little Wireshark. Okay. So that's the fun part. All right. So just to give you a little bit background in case you haven't used Linux in a while, because people forget that happens. Okay. I'm going to do a lot of Wireshark. I even gave you some YouTube videos. I gave you a cheat sheet on filters. The reason Wireshark filters are very important is so you can see that you've captured. Okay, because there's so much junk you're going to capture between going on. You're going to see a lot of traffic. This will allow you to capture pretty well. Okay. All right, let's start with some basic. Okay, so everybody remember what the RFCs are. What are RFCs? It's what makes it all happen. Recommendation for comments. These are the standards. Now, there are standards and then there are standards. Not all of them are strictly adhered to. Okay, so let me explain. There is a process by which any one of you could write an RFC for a new protocol. These are not programming. Okay, a lot of people don't understand. RFCs are frameworks. You say, this is the protocol I propose. This is the structure of the protocol. And it goes through a process whether or not the internet community as a whole around global will accept it. Okay. It's not that you sit there and writing, but what you're proposing is a standard. There is no code in these RFCs. You're not going to see any programming or that. You're just going to see, frameworks of how the protocol should look. Okay. Where this all came from is, anybody remember what the OSI model is? Remember that fun thing? Okay. The OSI model is just a teaching model. Okay. It's not we use it for teaching. It did have protocols written for it. They failed miserably. That's why we have TCP/IP. Okay. But the OSI model, or the original OSI, was put forth by the standards organization so that everybody would play nice. Networks never talked to you. IBM had its own network. The community wanted its general network. Everybody was making networks, but they never talked to each other. So they had to come out with a standard that say, everybody to play nice, we're going to follow this. Okay. Now, at the time, they wanted an open source protocol. Now there was a better protocol they could have used for the internet, but they didn't want to use it because it was owned by a company. and that was IPX SPX. Okay, it was owned by a company called Novell, and that protocol actually is better than TCP/IP. It's all long gone now, but it was actually a far faster and more efficient protocol. However, okay, they wanted something open source, hence TCP/IP exists. Okay, so let's take a look at. So if I put in, so a lot of people go, well, like TCP. Let's try that one. So notice what it says. This is in RFC 761, January of 1980. It was a protocol by who? DOD, like I said. This was all the DOD asked for these protocols to be developed. Okay, this was the defense industry. You wouldn't have had that at all. They wanted to talk to things. They want an open source standard. So here's the original one. How old is it? 1980. That seems like a generation ago, right? Okay. How many years is that? The internet's not that old, but it's close. Okay. This is just protocols to use, but it was proposed back in DOD. Now, once you look at it, it's just proposals. These are just discussions. What TCP, it should, support this. It should look like a header, and here you'll see looks very familiar. That's what the header should look like. There is no code in here. It's just this is the framework or the standard that was accepted. So all headers should look like this, yes. Yeah, it's what they recommended for comment. That's what it means. So you could write one. Say you could come up with a protocol, say it should look like this, should do this, how it would work and that. You don't have to write the actual code for it, but the proposal, and it goes through a whole process. And if it gets accepted by the entire world, everybody uses it. Or some of them just go into experimental. Some never make it out of proposal stage. Okay. Like I said, there's lots of proposals out there or protocols that exist that just haven't. So, like, I'll give you a recent one. Not me. I'm not smart enough. There's other people that are far better at this. But I actually have a colleague here that part of her class is you would actually submit a RFC. Pretty funny. She used to teach you how to do that. It was part of her class. Yeah. It was kind of fun. Okay. Like here is Quick. Okay. Quick, QUIC, is a protocol that Google put out. It's a UDP-based protocol. And they just introduced it back in like 21. Okay, this is by Google. They don't like TCP. I don't know why Google don't like TCP. They don't like TCP. So they want to make the web page load faster. Okay, what's the difference between TCP and UDP? Other than that, nobody be smartass and tell me they're spelled differently. Okay, what's the difference between the two? Very good. Well, UDP is connectionless, so you don't like jitter. Okay, people don't like jitter. Jitter is delay. And if I use TCP for video streaming, you would hate me because you would be talking right now and the video picture would be like 20 frames ahead and be very out of sync. She's like, yeah, that's what happens. They use UDP and they go, well, if it's not a guaranteed service, right? It's kind of like football team when they throw a football in the end zone and hope somebody catches it. What happens is you get a lot of buffering. You ever play a video on a slow network and then you see the ball go around and around and around? It tries to buffer. If packets get lost, it doesn't care. UDP has no way of talking back to the receiver, so, but it's great for streaming. It's great for other services because it's not a guaranteed service. I just throw it out there. It's great. Okay. TCP is guaranteed. Okay. So you ever get a package you had to sign for? You ever receive a package and you had to sign for it? That's TCP. TCP is guaranteed. Now, is the internet packet switched or circuit switched? Yes, because no dedicated connection. Now, you may look at me funny and say, what do you mean? The internet protocol, IP, that's a separate, doesn't give a shit whether it gets there or not. IP can go up, down, right, left. They can go through 10. You might try to connect to a server next door. You may end up going this way to Wisconsin, go that way back. It doesn't care. As long IP doesn't care. That's why the internet scales. TCP as a protocol goes with IP if you want a guaranteed service. The sender and receiver, there is no dedicated path. Okay, so what does that mean? You know the old telephones? You seen them in the Matrix or seen them in old movies? Some people still have them. Okay, those were two wires that would tie all the way back wired to the other phone wherever it was around the globe. The plain old telephone system was the largest network in the world. When you picked up the phone, those two wires tied to another two wires at the other end. So there was actually a dedicated line. Okay. That doesn't scale. Think about the billions of people that connect to Google every day. You would have billions of lines. You would be overloaded. So what they did was they said, nah, the only two people that need to know about the conversation are the sender and receiver. How the protocol gets there, we'll use TCP as a protocol if we want a guaranteed service to say, you sent me packets 1, 2, 3, 4, and 6. I didn't get 5. So the receiver would go back and say, TCP would go back and say, you're missing a package. Send me number 5. Make sense? Okay. UDP, it's out there. All right, good luck. Okay. You wouldn't tell if a packet's missing anyways in UDP because of the way the frame rates work and things like that and so much buffering, you can't tell things are missing. We use it for a lot of different services, and that's what Quick Protocol, rather than use TCP to connect to a website, because you do use TCP, and it causes delay. Ever like load a web page and it takes a while? That's TCP trying to, and most web pages interconnect other web pages. So has anybody ever have a web course in here or HTML, anything like that? They're pulling in other, but well, it's waiting, and TCP is like, come on, send me this, and it's taken. Then Google said that's stupid. We'll use Quick. We'll write this protocol that does it over UDP, and I get send it faster. Okay, but there's no error checking or anything like that. Yeah. Cool. Very good. That's good. You remember some of it, right? Okay. TCP is guaranteed, so that's where you have to sign for a package. UDP is, when UPS kind of throws it at your door at high speed and hopes it lands. Okay, I love it. I love when they don't take a picture. That's how you know they didn't deliver it. We delivered it. Where's the picture? There's no picture. Why does Amazon do pictures? TCP guaranteed delivery. I did deliver it. See the picture? That's not my door. Oops. I've had that happen. It was delivered, though. That's not my door. I don't know where you delivered it. Which has happened. Fortunately, the person who got it brought it. It was medical stuff I needed, too. So bought it, but it's like, you can't, I don't know how they delivered it wrong. Okay, but so TCP, UDP, and then IP is the Internet Protocol. That's the one that we use to send things, right? That is a protocol. And it's not guaranteed. IP doesn't care. Okay. Now, what I wanted to show you, more importantly, is since IP doesn't care, we actually use what's called ICMP to go with it. It's part of the standard 5. And anybody remember what ICMP is? It's what kind of protocol? Say, It's an information protocol. Basically, you wouldn't know if a packet got lost or not without it. It does. That's the way you message. There's actually everybody's ever pinged in here, right? You've used ping. Ping is a tool. It's not ICMP. It uses ICMP. It uses a message echo echo reply 0 and 8. There's about 30, 40 different messages that you could use in ICMP. You don't have. If somebody blocks your ability to ping, that doesn't mean that I can't use a different part of ICMP, a different messaging, one of their other messages to see if you're there. It's kind of funky. It's a large protocol. Okay, so we use ICMP to go with IP in order to tell you whether or not a packet is there or not, whether something has arrived or not. Otherwise, you'd never know. Okay, so those are some, right? At the base level of anything, you've learned at the base level, what's the protocol that on a local LAN that they use for one machine to find another machine? I know, I could see the smoke coming, right? What does a dog do? What does a dog do? Yeah, what does a dog do? Right, so to remember, the protocol at the bottom is an ARP. At the bottom, for one machine to find another machine on a local area network, it uses the ARP protocol. Okay? The address resolution protocol. These are the lower level stuff. I know this is a review, but I just want to make sure you understand how networks work, right? On a LAN level, at the local area, in a room or on a small network, ARP is the fundamental, right? What's that physical address? What do we call that? Is it? Yeah, good. I was going to say McDonald's, same thing. Okay, all right. It's the machine, right? Your cell phone. You go on the internet on your cell phone? Sure you do. Use a data line. There's two signals. One is for cellular, that gets you your voice. The other data signal on your phone gets you data. They're actually two different channels. So sometimes you can get voice and no data. That's because the second channel's not picking up. Okay, it's kind of funky how it works. I used to teach phone forensics. Anyways, the MAC address is the physical. Every phone has a MAC. Anything that's going to connect to a network has to have a MAC. Okay, that is a burned-in address. Okay, but I can fake it. I can lie and say I'm different MAC if I want. There's ways to do it, but by you can't change the burned-in one, but you can fake it. Okay, so that's possible. And what's the internet address is the what? What is that address? What protocol? I just said it. What protocol? Layer 3. It's the internet address. It's the internet protocol. It's IP. That's the address is what IP. Okay. Everybody's like, yeah, I remember. No, I don't. Okay. There. Just I just want you to get this down because when we get up to the top layer with services, you have to remember what's going on the lower layer. I'm going to open up Shark and go through Shark a little bit with you. So here. I know it might be decades away, but I love this one. Oh, that's kind of a fun one. Look at that one. Look at that. Ah! Okay. Okay. So, right, and notice there's different names for stuff. It's pretty cool. Anyways, down here at the data link, that's where your MAC address is. That's your machine access. And the protocol we use is ARP. Okay, that's how one machine finds another machine on LAN. We don't do that across the internet, obviously. It would cause a huge amount of destruction across the internet. Okay, so that's why we use the network layer across the internet. Okay, sometimes they would call it the internet layer, but we use logical addressing. That's what IP address is, or the IP protocol. Just like you have a dorm room number, right? It's a unique number. It's an IP address. It's a building number, room number. Okay. Okay. There's a ARP is down in there, and then ICMP is the messaging that goes with IP to tell people whether it is. Now the bottom is what's a switch? Don't all jump on it at the same time. What's a switch? Right. Does it have to be hardware? Inside of Oracle is a virtual switch. I can mimic a switch. It can be both. Okay, we're used to saying physical, right? And software defined. If you're looking at cloud computing, everybody know what a cloud is? They float up ahead, they go around, right? Cloud is nothing more a term, whether it's Google, AWS, or Azure. That's just somebody's data center, but they use virtual switching. Okay, when you put VMs up on those things, it's all virtual switched. You use software-defined networking, SDN, and you use virtual switches. So you mimic a switch. Hypervisors use virtual switching. Some of the more expensive hypervisors have some very expensive virtual switching. Okay, but that's virtual, so you can have a hardware or software, either one. You're not wrong that it's hardware, but it's also. So what's unique about a switch that's different from some? There's an older device called a hub or repeater. So what's different between a switch and that? It has to do with the protocol. What's the difference? Yeah, go ahead. Very good. Okay. My colleague who used to teach here, who's retired, used to be at the head of 802. Anybody remember what 802 standards are? So the 802 is the International Electronic Engineer Society. They set all standards. Why is wireless Wi-Fi 5, 6, 7? They set the standard what those are. Why is an Ethernet jack, an RJ45 port look the way it does? They set the standard. And these are accepted standards. They work with their counterpart over the globe at the ITU, and they set the standard. The switch does what it does because he was working with IBM at the time. He was at Bell Labs, and he always tells the story. It's a funny story. You'd think this is like a deep technical discussion, okay, but it's not. He was working at Bell Labs. Bell Labs is gone now, but there was Bell Labs at the time. And switches came, they built a switch. They created a switch. IBM wanted it to work one way, and the industry wanted another. So, how did they settle the matter? They went to dinner, had a bottle of wine and a fish, and a fish dinner, and they decided how the switches work. That's how technical I got. Okay. Switch uses what? I know you say, how does it know where to send it? What does it use? Good. It has a CAM table. So you have the MAC address and then what physical port. And they also learn. They're learning. They learn from other switches. So down you can do VLANs, but that's beyond this course and stuff with them. You can split them up and stuff, but they use a protocol. They use the MAC address. So they have a CAM table, knows where, rather than a hub where everybody goes in. It's like a rave. Everybody goes in and everybody knows them. It's like a big party. Okay, but we don't use hubs in general anymore. Okay, routers, and this is what runs the internet, use IP. IP is logical. Can your IP address change? Yeah. If you leave this building and go to another building, you might change your IP when you connect to the wireless. You could have all kinds of, it can change. The only thing that doesn't change are like the internet's, like if you got Google, Google has like 4 different addresses that they are fixed. They don't change because you don't want them to move. You want to find them. Okay, so those are fixed. Okay, but like on a mobile network, um, you want to be able to flip the addresses and use them. Okay, makes sense? Okay, and then you get into transport, and that's where we talk about TCP and UDP, which we had the whole discussion on. Okay, so you should know all the way up that these top layers are what basically combine it. They're not an application; they are a service. Okay, people keep saying email. That's not what we're talking about. We're talking about SMTP, which is the transport protocol for mail. We talk about POP and IMAP. You're going to build an email server in this class. Unsecured one, but it'll be an email server. So you can see how email works. And it hasn't changed. Works the exact same way as when they invented it. Okay, so you'll build an email server. But the protocol there is like SMTP. If you do file transfer, it's FTP. People say FTP should go away. The problem is there's nothing as fast as it. You generally, when you click, you download using HTTP. You're not using FTP, but FTP is far faster than any HTTP download. But they say, well, it should go away, but it's been around since 1980s, and it's fast, and you can secure it. So if you ever use FileZilla, that's a very secure, you just use secure FTP. Okay. Once again, this just to jog your memory. Notice something, data, when you make a packet, they call it an encapsulation. So the data is whatever you're going to put in the package. Segment is what TCP is. You cannot send 1 gig packets across the internet. They're broken in. The limit of 802.3 is about is a frame limit of 1500 bytes. So everything's broken into pieces. TCP breaks it into segments. Remember I said TCP, when you send something, it says I got piece 1, piece 2, piece 4. I'm missing segment number 3. TCP will go back and say, you lost me one, send me it again, and it will. UDP, it's like, got lost, okay. Okay. But segments are at TCP. Then you get down to packets, which is what IP, we call it IP. People get it a little mistake. And then down at the bottom, you get into frames. That's where you actually put a preamble on Ethernet. It's a preamble header and CRC, or if it's wireless, it frames it the same way. Okay, cool. This is coming back to you, or am I scaring you? Okay. This fundamentally, we're not going to delve in these areas, though you'll see these protocols all the time. But just to remind you what these things do, because when we build a DNS server, you jump various routers. Okay, so like if you open up, so you ever trace your, oops, I keep typing in Linux. Okay, I have to always remember what operating system I'm on. Okay, did you ever watch your connection across the internet? So you can do trace RT or trace route in Linux, either way. www.google.com. So what are all these hoppy thingies? What are these hoppies? So it's 30 hops max. What are those things? Well, there should be a hint there. You see, what's this? What is this ugly looking stuff over here? What is that? Yeah, it's IPv6, so it's internet addresses. So what are these hop things? Are they? They're not servers. They're not servers. You're close. They're routers. You're watching me hop router to router to router to router to router till I hit the final router that takes me to Google. Now this path is not a dedicated one. The next time I try it, it might go to different routers. I may end up go across the globe and come back again just to get to Google. Depends on whichever router knows whatever other router knows. It jumps around. This is why the beauty of the internet. That's why it works. That's why it scales. Okay. Now here's the dirty secret. You ready for a dirty secret? The internet was never designed for what you use it for. Everything in the internet was text. They only had text. There were no JPEGs, PDFs, none of that. They designed around sending text. That was how they designed it. That's why there's Internet 2 and a lot of other things. They never designed it to scale the way it did. No one foresaw, Cooper invented the cell phone. Marty Cooper he doesn't come too much, but he came here a couple of times. The guy who invented the cell phone. That he talks about it when he was at Motorola and invented the cell phone. They never anticipated stuff like that. The cell phone or tablets or game PlayStations or any of that. So they never scaled it for that. You got to remember the internet was mostly FTP servers and dial-up. All of it was dial-up. Okay. It was that annoying sound you'd hear as you dialed in. You still have fax machines that do that. So, but that's how it built from there. They never scaled it. Okay. That's why nowadays they have groups working on how do you shove more baloney into a 1 pound bag? Because the amount of stuff you put through the internet now never was designed for. There were proposals to tear down the internet and rebuild all those structures. That's not feasible, but they're trying to improve it because we ran out of IPv4 addresses. Everybody knows that, right? We ran out. They can't issue anymore. Now they go, but I still see IPv4. Yeah, companies still have huge blocks, and because you do natting, where you use private addressing versus public, they still have lots of IPv6. IPv4 around. IPv6 is 128-bit. You could have a unidecillion number, more hamburgers than McDonald's made in a lifetime addresses. And the reason is because you have a lot. How many electronic devices do you carry that connect to the internet? Think about it. She's like, I ain't talking, right? Average is 3. About 3. Usually a laptop, a cell phone, and maybe a watch or something. Usually average person about 3. You got to remember, laptops used to be desktops with a handle on them. I'm not kidding. They were the minimum requirement to be a PC tech back in the day was you had to lift 50 pounds because most of them weighed that much. It was like putting a handle on a full desktop, and the desktops were made out of steel. They weren't made out of plastic. This did not exist. Okay. So you got to remember where this all came from. Okay. Cool. So the internet wasn't built to scale. So what we have now is modifications to be able to deal with the kinds of traffic you're seeing. They never knew game stations or things like that. Yeah, you played some games. They're very crude. Okay. And when we get to that history, you'll find it very fascinating where it all came from. Okay. Cool. So just to jog your memory about the bottom layers. Okay. Just to remind you. Okay. Once again, it's all based going back to your RFCs. So there's lots of RFCs. You can read all of them. And one of the interesting things is you do not have to adhere perfectly to an RFC, just partially. You just have to make it work with other machines. Perfect example, on a local LAN. What's TTL? Was it? Time to live, right? The RFC states TTL is 64 milliseconds. That's all right. If I ping a Microsoft box, it will be 128 milliseconds because Microsoft decided to double the TTL. It doesn't violate the RFC because it doesn't make it less. It adheres to they doubled it. If I ping a router, it will be 255 as a time to live. Okay. If I ping a Mac, it'll be 64 because it's a Unix box. If I ping a Linux box, it will be 64 on a local LAN. So as I said, they can vary how they interpret the RFC. They won't make it less, but they will at least meet the minimum or maybe change it. It's how they want it. Linux implements the TCP/IP stack differently than Windows, differently than Mac. Mac implements the stack differently. When I'm talking about the stack, I'm talking about TCP/IP. Okay. Any developers in here, programmers? No. Okay. They just plug into the stack. They don't even say connect. They don't have any clue what's underneath the hood. They just connect to it. Okay. And there's a lot in there. I'm not going to go into all the minutia. If you're ever interested and you need some bedtime reading, Okay. There's a really good book. This is the guy who wrote a lot of it. So you could actually get it for free out of the Internet Archive nowadays. This is the book. You want to see how they programmed it or what that code looks like or just some basic how they design these protocols. It's a 3 volume set, but the first volume covers all the basics. If you're ever interested. Okay. If you need some light nighttime reading. Okay. That was Stevens is the book. Okay. Cool. All right. Let's go into now modern stuff we're going to work on. I thought Stevens was going to go. Okay. All right. It's like, I'm getting out of here. He's going way too far. If you need a review, I did put in the Canvas for you um, this little guide. It's a free book. Okay. If you want to review anything, you don't have to buy this book. If you buy it in actual paper, it's about this thick, about 3 inches thick. Okay. You do not have to buy. He put the whole book online. Okay. And if you want to learn, review yourself on TCP/IP or anything like that, I put the link inside of Canvas for you. Okay. So if you want to go through and learn all of the, remember some of the stuff, it's all here. It's everything that you'd ever want to know about TCP is in here. Um, there's actually, he writes a guide to the guide, except for the advertisement. But there is tons and tons of stuff in here, all about TCP, every protocol, all where it came from, and just how things work. Okay, so if you want a reference, this is a good reference. Okay, it's not required you to read it, but I thought you'd like a nice reference. Okay, if you want to review anything, or and depending on whatever you end up in, and is everybody going into IT in this class? IT. Okay, I was over 20 years in IT. You need to understand how networks work. Very important. Okay. You don't realize how much till you actually work in the field. You really need to understand it. Okay. So understanding this will help you, regardless where you go in IT. Okay. There's so many options, you'd be amazed. Okay. You got lots of fields in IT you can go to. And if anybody's interested in any industry certifications, just tell me. I got about a dozen. I can tell you how they work. Okay. Or what you need to study. Okay. Cool. All right. All right. Yeah, my background is not academia, just so you know. I come from industry. I started teaching, after I got laid off, I started teaching full time. But I've been teaching here almost 20 years. I was teaching here while still working. So my background's a little different. Okay. All right. Let's look at some of our fun stuff. So let's look at Wireshark. I'm just going to launch Wireshark. Okay, Wireshark's a cool tool. Now, I installed it on my Linux box. If it's still not looking on fire. So I installed it on my Linux box. Now, one thing with when I install on Wireshark on a Linux box, they've split, because they're using Lua, they've split the security. So you do have to sudo. Everybody remember what sudo does? Yeah, it's run as, basically. You know that there is a sudo for Windows? It's hidden in Windows 11. You have to turn it on. You can sudo in Windows. It's beautiful. Anyways, they're making Windows like Linux, just so you know. A lot of the stuff that's in Linux is appearing in Windows. So when you run Wireshark in here, yeah. Did I forget to load you? I must have. I had to rebuild my box. My entire computer crashed a week ago. That was very painful for me. And I got to thank Microsoft because their last update crashed my entire machine. I had to rebuild everything. That was a lot of work. So they issued a bogus patch. So it crashed my machine. I had built all this previously, and then I lost it all, and I had to start over again, which made me very unhappy for about 3, 4, or 5 days. I'm still rebuilding parts that I'm looking what I'm missing. So, but let's take a look around, and then I'm going to show you the raw capture. Now, I'm not going to keep you all the way till 9 o'clock because I'm sure you're cold and tired and all that. I'll probably be done probably around 8:30. You don't mind if I don't give you a break, do you? If I go at 8:30, normally I would give a break. But if I go to 8:30, your break's built in. You go home. Anybody got to catch the train? Or you're on campus? Okay. Sometimes people have to catch trains, so I usually done around 8:30. So, and I kind of skip the break because it's kind of useless to walk around the halls aimlessly. So, but let me get up Wireshark here. While this is loading, so well, that does that. Well, you go that way. Let's roll up a Wireshark. And then basic things I want to cover in Wireshark. Since you've used it, I'm sure you're masters of Wireshark. All right. This thing is not really designed. It can capture. Don't get me wrong, it's a sniffer. It is not preferable in the field to use it. It's more of a parser, which means it's great at analytics. Okay. Right. Really, you want to use TCP dump and dump the file to a PCAP and then throw it into Wireshark for analysis. I'll show you how to do that. TCP dump comes with Linux. You don't have to load it. It comes with it. Wireshark does not. You have to load that, but it's free. So if I turn on the wire, you see, look at all that beautiful traffic, right? All that shit going through here. What's nice is there's two things. You could set capture filters. So if you wanted, you can actually set what the capture, you could set that up. I prefer capture the traffic, and then I will apply a filter. Okay. Wireshark has a ton of filters. They're based on OpenBSD. Now, they actually come from TCP dump. I give you a cheat sheet. Did they remove packet life? No, they did not. I know why you did that. I know why you did that. Hold on. Ever since they updated Canvas, it gives me a heartache. Yeah, that's right. But I take down my favorite site. Ah, there you are. Oh, wow, they took it out. Oh, well, I'll have to give you a new cheat sheet. They moved it? Oh, they moved it. Okay. I'll have to find it for you. They've taken down my site. Since Cisco got hands on it, they took it around. Anyways, I'll put up the actual PDF then. But this is what I was trying to show you. These are filters. Now, you probably use some of these. Have you ever filtered before? Display filtered in Wireshark a little bit? There are lots of subcategories. Like I can go down to flag fields. I can do all kinds of fun stuff. This will make your life easier. Okay. So if I'm looking for DNS request, I can pull them pretty easily. Okay. Because like I said, there is a lot of traffic going on. Let's take a very simple, I'm going to stop. Take a look at a packet. Okay, very simple. Okay. Now, I'm going to do it the ugly way and I'm going to do it the nice way. Okay. So I'm going to do File, Edit, Preferences. I'm going to do it the hard way and I'll do it the easy way. So what is this mess? Is it? Bunch of numbers. It's hex, right? That's the actual traffic. It's done in what's called big endian, which is the big end. If you count a byte, how many bits in a byte? How many? 8, right? You count from 1 to 128, right? The big end is 128, the little end is 1. This everything is in big byte order, so the high end goes out first. This is the raw traffic. So if I'm looking at DNS, right, and I look at it, it's interpreting this for me. So this is how you read. So the thing is reading it for me. Okay, kind of cool. In an advanced networking class, you would read it in hex. It's painful, but you can. Okay. It's like, I don't do that. Okay. But you got to remember, you're trusting the reader to tell you that that's correct. I'm trusting that this is the correct answer to that. Okay. So if I really wanted to read it, I wouldn't look here. I would just read the hex. Each byte field is specific. Okay. That's for advanced networking, but that's fine. But there is fleet. So what is DNS? DNS is what if I'm looking at the protocol stack, what layer am I at? Nope. DNS would be where? Where is it? Oh, I know it's a domain name, but in the protocol stack, right? I showed you the stack. Where is the DNS protocol? It's not 0. It's not at the bottom at 1. So where is it? It's layer, right? If it was OSI, it'd be 7. It's TCP. It could be 4. It's right at the top. So this is the top of the packet. This is the bottom of the packet. Okay, right? And all I'm reading is this frame right here. This frame is this. Okay, makes sense? Okay, I'll make this simpler for you. Here, watch this. Anybody ever seen a protocol diagram? At least once? I'll make it easy. Hold on. Yay. So if I hit that, this is how the packet is laid out. Okay, so for the header, and that's the header, the DNS header, this is how it lays out. Okay, who defined that? Starts with an R. Go with it. Close. RFC. Somebody defined how that lays out and what should be in those fields. You can look it up. Okay, I'm not going to go there. But you can see this is the layout for that. Okay, what kind of protocol is DNS in this case? I'm going a layer down, so I want application. Now I'm going down a layer. What's the layer below application? No, that's OSI. And TCP/IP, application, presentation, and session are all one layer. What's below that? Transport, there, layer 4, right? So what is DNS in this case? What am I using? You're looking right at it. What am I using? Don't be afraid. Yay, there we go. So DNS uses UDP. Now I'm going to tell you, some protocols use both. DNS can use UDP and TCP. Uses TCP for zone-to-zone transfer between a primary, a tertiary, or secondary server. And it's authenticated, so you're not trying to spoof it. So it'll use TCP when it has to talk from one DNS server like here we have two, at least two. When it talks to one DNS locally to another, it'll use TCP to move the records. Okay. Otherwise, when you do queries on the internet, it's UDP. Now, this was the beef with why we have why they want to do secure DNS. It's called DOT. Okay. There is a proposal, it's in the RFCs, and if you use anybody use Mozilla Firefox? Okay. If you set your machine to 1111, That's their DNS. They encrypt all your DNS queries. And the reason they're complaining, what they're doing is they said, here's the problem. DNS is UDP. It is unencrypted. And so therefore I can open it up and read what you're asking for. I can read what you're querying. So the argument by the people who proposed this is that your DNS, they could see what you're doing, so therefore it should be encrypted. The argument against it is that most of our blockers are based on what's in the DNS traffic. Okay, so there's an argument in the industry whether that should be allowed. But Mozilla will do it. They have a specific setup where they'll encrypt your DNS queries if you're using them as a DNS server. Okay, but here's UDP. Notice here's the UDP layout: source port, destination port. What's a port? It's where a boat docks. No, where is it? What's a port? Don't all rush to answer. Go ahead. Very good. No, actually, that's great. I use the Motel 6 analogy. You got a bunch of rooms, right? You only get a key to one room, right? That's what a port is. How many ports are there? Yeah, that's a good answer. Crap that. No, 65,536. That he knew. Right. We only need to know 0 through 1023. I'm going to make you remember. No, I'm not going to. Okay. 0 through 1023 are the well-known ports. Okay. Then there's a block in there that are registered, and there's a whole bunch of free ones. There are 65,536 ports. Notice the port, so it's going to a 53, which is the destination. Now, you say, okay, it goes to port 53. Does it come back on 53? Where did that port come from? Okay. So it comes back on it. The answer comes back on a different port. It's true for all protocols. People think, well, if I query a web server, it's going to come back on. No. It creates either it's got a port it sets up, it's called an ephemeral port. So the protocol, the query, like what your browser does, it creates its own port, whatever its source port, it generates that number. It picks a random. Microsoft Edge likes 1024 to start, and then we go from there. But the destination doesn't change. You're going to a definite service, okay, or the definite hotel room or whatever, whichever door it is. Coming back, it'll come back on an ephemeral port chosen by the operating system and or browser. Okay. The only one that we're going to find is one exception, and that's because they made a mistake. We'll get there. We'll get to that protocol, but that's because the people who wrote the protocol made a big boo-boo, and they did not. They created a fixed two ports that are fixed. They never change. We'll get to that protocol. It was a mistake. Yeah. No. Destination is 53. Coming back, it could be any port that the query decide, whatever the source is. Okay, makes sense. You don't go 53 back to 53. Doesn't work that way. Okay, every service will have what we call an ephemeral port. That means a port that the service that's asking will create. It doesn't necessarily have to be 5,000. It could be anything it chose. Okay, that's where the answer comes back. Okay. When you go to the destination, that's a fixed port. That one's set. If it's DNS, it's 53. If it's SSH, it's 22. If it's FTP, it's 21. 20 is control. If it's SMTP, it's 25. If it's POP, it's 110. Okay. Why do I know these ports so well? They're well known, and we don't use port 80 anymore, but yeah. It's unsecure. 443, right? The reason you have to know that is firewalls. And if I was an old comedian, I said, is that a wall on fire? No, it's because of firewalls. Because you have to configure for firewalls. Okay, because you have to understand the protocols of where they're going out, so you know what you set your firewall to. Otherwise, most times people never configure their firewall right, and that's where they have problems. Okay. I had a guy that he used to do telephone systems. Okay, and telephone systems are heavily firewalled, except for the billing system. So you know how you get your cell phone bill and stuff like that? In order for the billing system to work, it bypasses the switch security and goes behind the firewall. It has its own firewall. The problem is that as he said, people who put those in don't configure them. They actually, at one time, he went to some vendor put a firewall on the billing system. He had the rules backwards. So there are three sets of rules: incoming, ingress, egress, outgoing, and DMZ. Okay. They reversed the outbound and inbound rules, so everything could get in. um, you got to remember, you have inbound, outbound, and then usually you have what's called a DMZ zone, which is for things that have to face the internet, but you don't want them to be direct connected. So knowing how protocols and ports, that's how you do firewalls. All the firewall, because understanding which ports to use. That's why when people load stuff on their machine, it says, I need to go through the firewall. They go, oh, sure, yes. And they open up a port. Now, what happens when you uninstall an application on a machine? If you open a port on a firewall and you uninstall the application, what happens to that port on a firewall? No, nothing. It remains open. Even if the application's out there, it's still open. You never closed it. It doesn't automatically close. Okay. That's why ports are important, understanding which ones. Cool? There's a reason for my madness. Okay. Protocol, I mean, this is where this is all your data, right? If you don't understand how it flows or what's in it, they steal from you. Okay. All right. So let's take a look. So here's UDP. Notice there's nothing or other, just the payload. That's all. Source destination ports. So those are the ports. But do you see an IP address in there? No, because you need the next header, right? IP header, right? Remember, each thing, it's like Aunt Martha's fruitcake. She looks at me funny, right? There's this fruitcake that goes around an entire family because nobody wants it. It was made by Aunt Martha. So every Christmas people ship it to one another, to different people. So how do you ship something? You first get a box and you put Aunt Martha's fruitcake in it. That's the data, right? Now you got to ship the box. So I have to give it a header. So I have to give it source and destination address. Okay. Then I have to decide, do I want the person receiving it to sign for it, or I'm just going to throw it and hope it gets lost somewhere in the mail? TCP or UDP. Does that make sense? And the poor schmuck who gets the package encapsulates it, opens it up. So when you make a packet, it's encapsulation. When you open it up or open up the box, you find Aunt Martha's fruitcake, that's the encapsulation. You're taking it out, right? So same thing. It's like shipping a box. Computer is nothing more. It's just shipping a box. It's just they've come up with a system using protocol to move things. That's how data moves. Okay. Now, one thing to note is I put an IP header, right? How did the package know it was UDP? Got to remember, machines are numbers. How does it know it was UDP packet? How does it know it's a UDP packet? Inside of the IP header, you define the protocol. All protocols have numbers. 17 is UDP, 6 is TCP, ICMP is 1. Machines do not read human language. Remember, I go along and it says, how does IP know what kind of packet it is? Because it's got a protocol field and it says, oh yeah, that's a UDP packet. Does that make sense? It says, as I strip it, right, I'm going to hit the IP header. It says, well, is this a TCP or UDP? It's UDP. So therefore, I'm not guaranteed there's not going to be segments here. And I go back up all the way up the tree. Every protocol has a number. It's not a port number, it's a protocol number. Okay? That's how machines understand things, by numbers. They don't understand human language whatsoever. Everything's assigned a number. Okay? Does that make sense? And you can look them up if you want to see them there. Do, 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 do. 150 rows. So every protocol, so protocol number 1 is ICMP. So if a packet was ICMP in the IP, it'll say 1 in that field. Okay. TCP is 6. So if I have a TCP packet, I go in the IP header, it looks in that field, it says, is this going to be a TCP packet? Remember, packets got to be de-encapsulated, right? So they have to be stripped from the bottom up, right? Make sense? Anybody lost by what I just explained? Here, watch this. I'll filter. Just give me a raw TCP packet. Here we go. There's lots of TCP. Here's a raw TCP packet, just TCP. Here's the IP header. So it's a TCP packet. It's going to, from a secure 443 back to some ephemeral port. I open up the IP header. There's the protocol. It's number 6. Therefore, this is a TCP packet. You just got to keep in mind everything is assigned numbers. It's easy to read like this, but it's a hex field. It's 06. Okay? Does that make sense? Okay. This is basics of how protocols work. Okay? Yes. Mm-hmm. UDP would be marked in the IP field. Quick is a UDP protocol, yes. It may, I don't know if they've assigned it a number yet. Hold on. It's not fully accepted. Hold on. I don't know if they've given it a protocol number. Let's see. Nope, they haven't given it its own number yet. So it just rides on UDP. They use UDP as the protocol. Quick is really an application layer protocol. So it's kind of like, let me explain. You ever remote a machine? Remotely connect to a machine? So you're riding on top of the stack, usually it's TCP stack, okay? You're at an application layer, okay? So Quick in itself rides on UDP rather than TCP. HTTP rides on TCP. Does that make sense? Or are you still confused by that? Well, because it has to know what the protocol is. HTTP as a protocol, as a service, as a port number. Okay. Quick is a new protocol that rides on UDP. Okay. It's a little twist on it. Okay. There's a company called Citrix. If you've ever run across Citrix. Citrix is a remoting ability to run thousands of machines remotely and they invented this thing. They write a special modification to the application layer They use the standard TCP stack. Everything from TCP down doesn't change. What they did is they twisted and optimized the application layer, their service. They can run over a modem line, which is 56K, and still remote a machine. So they customize the top. You can do what you want with the top application layer. Do whatever you want. Write your own stuff there. You cannot change what's below. TCP is founded. UDP is founded. You can't change down there. You can change above it, but you can't do below it. The stack has to work. Otherwise, you can't talk to nobody. Okay. So the lower layers up to layer 4 do what you can't do anything. That's the way the internet. That's how until they radically redesign the stack. Those are standard. Anything above that, it's up to you what you want to design. Okay. So if you want to design a new protocol, go ahead. Okay. There's people who do it. They design all kinds of protocols. There's some really wacky ones. Okay. Cool. Answer your question? Very cool. So, like I said, TCP, here's the IP header. Remember what a header is, right? Okay, it's going to have, okay, this is IPv4 headed. More importantly, it's got source address and destination. So like when you mail a package, where is it coming from? Where is it going? Okay, and it has something unique called flags. Anybody remember what flags do? This is going back in time, I know. No, well, I get it. Whether flags on, no, that's a good answer, but that's not exactly what the flags do. It's a good. I'm not. It's a good answer. What is unique about TCP other than it's guaranteed? What does it do that UDP doesn't? Involves these flag fields. Go ahead. No, that's a flag. So how do I guarantee a connection? I want to make sure this one knows about that one, and there's no dedicated resources about it between them. Remember, it's the internet. There's nothing. It's not like having two cups and put a wire between them. Ever do that as a kid? And you could talk in one cup, it vibrates the string. I know I'm old. Anyways, okay. That's a dedicated connection. Internet doesn't work that way. Okay. If it did, if it worked like the old way, dedicated, we'd never scale. We scale now. We do more hamburgers than McDonald's does. Okay. But I have to guarantee. So what is unique about TCP? It uses these flags. Yes, go ahead. Good. She got it. It's a three-way handshake. It says sync, and then you say, oh, here's my sync, and I acknowledge you. And then I acknowledge you that you acknowledge me. Okay. Once that's established, you now have sender and receiver knows each other. Okay. And then we have flags to break that connection. That's the FIN flag. Okay. So there's a SYN flag or sync flag, the ACK flag, the FIN flag. Okay. And then there's the reset, like you said. When something it doesn't have a connection, it resets it. Okay. We don't do that in this class. That's when I teach cyber, when I teach pen testing in my other class. You reset it resets. Okay. And then there's also two special ones. Anybody ever see an ambulance flying down the street or a fire truck or stuff like that? A first responder. Okay. Inside of those, I used to work on these. Inside of those vehicles is a Panasonic Toughbook. How do I know this? Because they're the only ones that make them for first responders. You can run those things over and nothing would happen. They are just slightly less. They can't take a bomb. Military version of it can take a bomb. They're titanium. You can hit them with a sledgehammer, nothing happens. You could throw them off a mountain, nothing happens. These notebooks are indestructible. And they all have them inside those vehicles. that application they use is for dispatch. Everybody know what dispatch is, where you call in and they send the emergency. Things can change all the time. So suddenly you get a call, the location's here, but what if it changes at the other end? How do you get it updated? Now, they use cellular networks. Okay, there's no dedicated cell networks. That's how they reach those things. So in order to make sure what the dispatcher puts on the screen and that application inside the vehicle, they use the TCP flags urgent push. So what it does is every time that screen changes at the dispatcher, urgent push is used to update the screen in the vehicle. So if the dispatcher said, oh, location change in there, it would automatically push it quickly, and that's how those apps work, to refresh that screen. Because you never want the wrong info on that screen. Does that make sense? So they actually use TCP. I used to put an analyzer on there and watch this thing do this. It's tons of urge pushes, and it keeps updating the screen. Okay, so if the dispatcher changes something, it'll update the screens, because these are moving vehicles, you got to remember. You know, they're moving and things could change, and you're on a network that's cellular, so. Okay, cool. So those flags in there, so here are the flags. FIN, SYN, reset, or RST, push, AC, urgent, okay. We never use that one. I don't know why they put it in there. No one ever used it. I have a friend who works for Cisco Systems. I actually asked him, I said, you know, you got routers, right? Run the entire internet, and you get all this traffic congestion. Do they ever use that flag? He said, no. Nobody does. It's been in there since the protocol is designed to warn you that you're overloading a connection, and they don't use it. They use a different protocol. They use OSPF, Open Shortest Path First. Okay. So, but that's TCP, right? So here's the flag field. Okay. So IP will always tell what the protocol is being attacked, what the header is, whether it's TCP or UDP. Okay. TCP will guarantee the connection will have flags involved. Okay. Notice the source destination fields. Okay. Cool. Makes sense. And finally, you got your lower levels. So you got your MAC addresses, layer 2 information, and then your header. This is basically, it's an 802.3 frame. So it puts a preamble, a time frame on it, and a CRC at the end. Okay, cool. Wireshark is your friend. You can learn a lot about things when you do Wireshark. I'm going to show you a neat little trick. So you want to check if you did capture the right thing. Okay. Flow graph. Everybody see what I did? Like, this will help you. So go under your, show you again. Statistics, go to flow graph. It draws a ladder diagram for you. So you could see your actual protocols in there. And it tells you what frame it was. Cool. So when you're capturing traffic, if you want to verify what happened, you get a flow diagram. It does it for you. You don't have to figure it out. You guys ever do flow diagrams for? Where you map them out? Okay. Kind of cool. This helps you with that. This tool is incredible. I met the lady who is like the master at Shapel, she knows this tool better than the people who wrote it. If you ever get to take anything from Wireshark University or Wireshark Academy, Shapel is the lady that runs that. She's a master at that. She knows protocols better than protocols. Okay. Very nice lady. Extremely talented. Should drive you crazy with this stuff. How do I know this is an encrypted packet? We're going to learn this TLS. You're going to make your own, you're going to insert SSL into a web server you're going to build. You're going to make your own certificate. You're going to do a web server. You're going to make your own certificate, insert it into the web server, and capture the TLS traffic. How many know what SSL is? What is it? Secure socket layer. Okay. It's broken. We don't actually use it. They still say we use it. We don't actually use it. It's been broken for years. We use TLS because it's subject to what we call a poodle attack. Mean little poodles attack it. No, it's something called attack. It's incredibly broken. We haven't used it in years. But they say SSL because we know what SSL is. It's really TLS. Okay. That's why you see this. Okay, cool. Questions so far? Pretty cool. There, let me show you one more thing. So this is a packet I have, a package I have. This has about 85 different protocols in it. It's great. So if I want to demonstrate something, I use this in a lot of, I like DHCP. How many know what DHCP is? Yes, you're going to build one. Okay, you actually could put the whole code in a chip. It's less than 8 bits, small little code. Anyways, what does it do? It gives you IP address, subnet mask, gateway. It can be a time server. It could give you, for TFTP, can give you where to download. It give you all kind of info. Okay, depends on who programs it. But notice DHCP. It does what I like to. It's called DORA. Discover, offer, request, acknowledge. But let's take a look at it. If I look at it, what kind of protocol is DHCP? Guaranteed or none? Don't be bashful. Is it guaranteed or not? You're looking right at the answer. It's UDP, so it's non-guaranteed. So when you hooked up your laptop, there's a server out there listening, waiting for you to come talk to it. Now, here's my dirty secret. Look at the port and look at the destination. It's fixed. They goofed up. When they designed the protocol, they tested it and forgot to change it. So now we're stuck with it. It will always be 67 and 68. It will never be anything else. They screwed up when they wrote the damn thing. They were supposed to change it, and they never did. So it'll always be the source is 67, and it'll be a server of DHCP. In this case, you're talking to wherever they're at. I didn't do the survey. There's an access point somewhere in this hall. I could find it. And it's basically feeding you an IP from an IP pool. They give you IP, subnet mask, all that, in UDP form. Okay. So they're actually giving you, you'll see something called boot. I'll explain what this is. That was the original protocol, was BootTP. Okay. It's still in there. I'll explain why. It's an old protocol. I'll explain why when I get there. That's towards the end of the course. But notice what it gives you. IP, it could give you server, MAC address. But look at all those options. Ooh. I can give you a lot of info if I want to. Okay, we'll get into that protocol later. But the important part to understand is that there's different protocols doing different things. So like HTTP, that's unsecured. There it goes to port 80. What's the coming back to 43625? It just made it up, whatever port it chose to come back on. Cool. What kind of protocol is this? TCP. So HTTP is TCP. And we can open up the protocol, and guess what? We go to that field. It's protocol 6. So IP defines it. Okay. Cool. Some basic stuff. I want you to get good at reading the traffic, understanding the traffic. Because, you know, when you're sitting on a network, like, what the hell's going on? You're going to get all this traffic. You got to be able to filter and figure out what's going on. Okay. I used to have to troubleshoot, like, why is this slow? Okay. Well, you're dumping a million packets at this way, and you're doing it this way, and you're slowing down as it's doing that because it's trying to write, you analyze things. Okay. Now, here's the raw way of doing this, and this is a way you can learn. Now, you do this in Linux. Thank you. So you can do sudo Wireshark, and it looks exactly the same in Linux. No different. We just make sure you sudo it if it comes up on my Ubuntu box. It doesn't like me today. It's aborting. I bet you I'm gonna have to. The problem is my machine just crashed right outside when I was doing something, and now it's screwed up. I gotta reload it. So I can't get the Wireshark working right. I gotta reload it. So there's something called TCP dump. I forgot my interface. Hold on. Interface is ENP0S3. So I can do TCP dump on interface ENP0S3. I can't type, so okay. Oh yeah, I'm using raw sockets. There's the traffic flowing through. Did you see why I said filtering is a problem? Okay. All right. Now this is just a Linux box running inside my virtual environment. Look at all this traffic. Okay. So how do you get around it? Well, I probably captured, 600. I could just write this to a file. Make sure you put .pcap on your file. Otherwise, Wireshark won't like you. Also, let me give you one other hint. They have a glitch. You see that .S0? Make sure you put that in there, otherwise it won't capture the entirety of the packet. There's a funny glitch in Wireshark that sometimes, depending on version, it's fine, but I want you to guarantee to capture all the packet. So put the -S0 in there if you're using TCP dump. Okay, this will guarantee you get the packet. Okay, once it's done, it's done. I captured 84 packets. If my Wireshark would work, but it's not, I could open it in the parser. My Wireshark is dead. You know what? I'm going to try it. I'm going to sneak it in. Let me see. Will you behave now? Yay, it'll work if I pull it that way. Except it won't work if I try to do a sudo. It's funny. Where'd you put this thing? Oh, I put it in root. That's why it's mad at me. Swore I put it in root. Thought I put you in root. Where am I? I'm in root. Don't tell me I put it in root. No, I didn't. That's been a pain in my ass. Sometimes Linux does not like to play nice. Where are you? Format. It's in there. You just don't have. Anyways, you could open in wire. I got to fix my Wireshark. It's in bad shape right now. It should have worked. Anyways, it's not taking TREFs. I know you're not taking TREFs. Used to take just raw PCAP. Okay. You should be there. Okay, whatever. You're going to be hard on me. I'll fix it later. Anyways, you could open it in Wireshark and then find what you just captured. Okay. TCP dump is nice except for the fact. I'm going to show you something real ugly. Yes. Am I SSH to my server? I am SSH. See, I lied. I went to the wrong server. Thank you. I didn't notice I was still SSH. That's what it looks like in the raw. That is ugly. Okay. You could actually filter that. But if you want to use TCP dump, you could just capture it and throw it into the PCAP. Okay. Cool. Yes, you're right. I am in my server. I forgot where I was. Now I'm on my desktop. Okay. Yay. Okay. Thank you. I feel like a fool. No, I don't. I often forget where I am. So it's on my server. That's okay. This will probably crash by the end of the semester. It always does. What do I want to do with it? That'll work. Yeah, whatever. Let me dump this one more time. You know what? I put Wireshark on the other machine. Watch. I bet you I did. No, I put it on this one. Okay. Thought I put it on the wrong one. There you are. Now that you're on the right side. I don't have filters. I can't open it. Oh, it didn't capture anything. That's why, you silly goose. ENP0S3. Oh, the server's making all the noise. Okay. Let me make some traffic. Okay, cool. I don't care. I don't care. Yeah, I'll generate about 1,000 packets right there. 3,533 just to open a website. It's a lot of traffic. Okay. And that's just opening a website. All right, just take a real quick look. Should have 1,000. There you go. Kind of cool. Easy to do. And then you could filter on it. Once again, since you are on a NAT network and you go, Professor, how do I get this into IIT? You're on a NAT network, so you can open up Wireshark and do portal.iit.edu and go into Canvas. It's not going to block you from that. Okay? So if you want to upload the PCAP that way, you can. You can even open up your Google Drive, or we're on OneDrive now, Microsoft, but and drop it right. It's not going to block it. So, okay, cool. Makes sense. Okay. Any questions about the class or what we're going to do? Okay. What I want you to do. This is not graded, but get your lab set up. Okay. Spend some time building your lab. Get your client and server. Okay. Make sure they talk to one another. Okay. The biggest problem I have is you build the machines. I'm ready to go, and you don't realize they don't talk. Make sure they talk to one another. Make sure you can ping between the two. Okay. Next week we'll start the first protocol. That'll be DNS. We'll go into all the minutia of DNS, and then you're going to build a DNS server, a bind server, as it were. Okay. And then you're going to build your own and to capture the traffic, and that's going to be your assignment. Okay. So that'll be your first protocol. Sound good? Right? Any other questions? Like I said, if you got to reach out to me, email's fine. Okay. If you're really desperate, you call Google, but let me know you're in this class. Okay. And usually I'm here an hour before class. Okay. So many ways to reach me. Once again, this recording, the Panopto will be up at the end, but I'm doing YouTube right now. So when I stop it, I'll process it and I'll send out an announcement if you want to watch it on YouTube. It's up to you. Okay. And I am doing, you guys didn't know I had this up, but I am sharing via Zoom. The Zoom links are in there. So if for some reason you can't make class, please don't all jump on me. Anyways, but I do this as a service to you just so you could have in case. Okay. Don't use it as a crutch that I don't want to go to class today. Okay. All right. Have a great rest of your week. I will see you next week. Okay. Mm-hmm. Okay. Mm-hmm.